Imagine a world where rivers were barriers, mountains were obstacles, and oceans seemed endless and perilous. Travel was slow, trade was risky, and engineering was limited by imagination as much as by materials. Then came a man who would challenge every assumption. He built bridges that defied gravity, tunnels that carved through solid earth, and ships that sailed faster and farther than anyone thought possible. He pushed machines to their limits, redefined engineering, and reshaped the 19th century world. His name was Isambard Kingdom Brunel. Visionary, perfectionist, and relentless, he combined technical genius with audacious ambition in a way the world had never seen before. Born in 1806 in Portsmouth, England, Isambard Kingdom Brunel was not destined for ordinary life. His father, Marc Brunel, was already a celebrated engineer, an inventor who had fled the turbulence of revolutionary France with knowledge, ideas, and blueprints. From early childhood, Isambard was surrounded by machines, tools, and drafts of bridges and docks. While other children played in the streets, he spent hours studying the mechanisms of mills, the framework of bridges, and the movement of ships. His curiosity was insatiable. He sketched designs that were far ahead of his age, blending artistry with precise mathematics. Brunel's genius was not merely inherited, it was nurtured by an era. The Industrial Revolution was transforming Britain. Factories rose like fortresses, steam-powered engines replaced horses, and iron and coal became the backbone of progress. Railways began to crisscross the landscape, shrinking distances and connecting cities. Britain was the heart of industrial ambition, and in this environment, Brunel thrived. He was not just another engineer, he was a disruptor, someone who would question every limitation of contemporary engineering. Socioeconomic conditions, philosophical underpinnings, early catalysts. The Britain into which Brunel was born was a land of sharp contrasts. Cities swelled with workers seeking opportunity, while rural populations faced hardship. Factories and workshops dominated urban life, yet traditional agriculture still shaped the countryside. Steam engines powered mills, coal-fueled furnaces, and ironworks transformed raw materials into tools, bridges, and machines. Society itself was shifting from manual labor to mechanized industry. Brunel inherited more than talent from his father. He inherited a philosophy. Marc Brunel believed that engineering was both art and science. Structures were not merely functional, they were transformative. Bridges, tunnels, and machines had the power to reshape society, connect people, and expand the limits of civilization. Isambard absorbed these lessons but added a quality all his own, audacity. Where his father calculated every risk, young Brunel challenged it. He was impatient with the ordinary, skeptical of limitations, and fascinated by scale and innovation. His education reflected this duality of theory and practice. At 17, he joined the Institution of Civil Engineers in London, surrounded by the leading minds of his era. Here he studied mathematics, mechanics, and architectural design, but Brunel's true education came from observation. He spent countless hours at docks, shipyards, ironworks, and bridge sites, absorbing every detail. He learned not only how structures worked, but why they failed, and how innovation could overcome failure. Every challenge became an opportunity to refine his ideas. Early projects revealed his remarkable combination of intellect, creativity, and courage. By the age of 22, he was appointed engineer for the Thames Tunnel, a project that had stymied and bankrupted previous experts. The tunnel ran beneath a river, through shifting mud and unstable clay, a task many considered impossible. Brunel embraced the challenge. He studied soil patterns, devised new support systems, and experimented with early tunneling shields, inventing techniques that would be used for generations. The Thames Tunnel became more than a project. It was his proving ground, where audacity, technical skill, and resilience merged into a single vision. Brunel's origins were shaped by more than talent. He grew up in a world demanding innovation, with mentors who embodied ambition and a father who celebrated audacity and invention. He was immersed in the language of machines and structures from birth, trained in precision, and encouraged to dream beyond convention. These influences combined to create an engineer whose work would not merely meet the needs of his time, but redefine what was possible for the future. Even as a young man, Brunel displayed a fascination with scale and speed. He envisioned locomotives that could cross continents, bridges that could span vast rivers, and ships that could cross oceans faster than ever before. This visionary mindset, born of talent, environment, and ambition, would drive his career and leave a permanent mark on the modern world. By his early 20s, Brunel had already set the stage for a life of revolutionary engineering. His origins reveal a man forged by intellect, environment, and audacity, a man prepared to transform Britain and ultimately the world. By the 1830s, Isambard Kingdom Brunel was already making a name for himself as a fearless engineer willing to take on projects deemed impossible by others. One of his first monumental tasks was the Thames Tunnel, a project that had confounded engineers for decades. The tunnel, designed to run beneath the Thames River, was beset by flooding, collapsing walls, and near-constant danger. Previous engineers had abandoned it, but Brunel approached the problem with a combination of ingenuity, courage, and meticulous planning. He introduced innovative techniques such as a tunneling shield to prevent cave-ins, which allowed workers to advance safely through unstable soil. The tunnel became more than just an engineering challenge. It was a personal proving ground. Brunel faced near-fatal accidents, including floods and collapses that trapped workers. Each failure tested his resolve, but also taught him the importance of persistence, careful observation, and calculated risk-taking. This project shaped his approach to all future work. Every challenge was an opportunity for innovation, every limitation a puzzle to solve. While the Thames Tunnel established Brunel's reputation, it was his work on railways that truly revolutionized transportation. The Great Western Railway, GWR, connecting London to Bristol, was his first major railway project. At a time when most railways followed the contours of the land to minimize construction costs, Brunel imagined a line that was straighter, faster, and more comfortable for passengers. He advocated for broad-gauge tracks, wider than the standard gauge, believing they would allow for higher speeds and smoother travel. This decision sparked heated debates among engineers and investors. Critics argued that it was expensive and unconventional, but Brunel insisted that long-term efficiency and passenger experience mattered more than short-term savings. Constructing the GWR was no simple task. Brunel had to design and build massive bridges, viaducts, and tunnels. The Box Tunnel in Wiltshire, stretching over a mile through solid rock, became a symbol of his daring vision. He personally surveyed the route, calculated gradients, and designed structures that combined engineering precision with aesthetic beauty. His bridges, often made of brick or iron, were as much works of art as functional infrastructure. Each project carried enormous technical challenges: unstable soil, unpredictable rivers, and the limitations of contemporary construction materials. Yet Brunel thrived on these challenges. Ships became another arena for Brunel's ambitions. In the 1830s and 1840s, steamships were evolving, but they were slow and prone to mechanical failure. Brunel envisioned vessels that could cross oceans faster, safer, and in unprecedented style. His first major ship, the SS Great Western, was designed to cross the Atlantic in record time. He combined innovations in hull design, steam propulsion, and structural integrity. Skeptics doubted that a wooden steamship could endure long ocean voyages at high speed. But Brunel's calculations proved precise, and the Great Western sailed successfully, establishing his reputation as a maritime innovator. Throughout these projects, Brunel faced continuous opposition from financiers, rival engineers, and even political figures. His insistence on bold ideas and unconventional methods drew criticism, yet his results spoke louder than debate. Each triumph, whether tunneling under the Thames, constructing the GWR, or launching transatlantic steamships, demonstrated his unique ability to marry vision with technical mastery. Brunel's early career was a study in risk and reward. He pushed materials, workers, and existing technologies to their limits. Every project presented conflicts, financial constraints, technical limitations, and public skepticism. Yet his resilience, combined with extraordinary foresight, ensured that these conflicts became stepping stones rather than barriers. By the late 1840s, Brunel had established himself not merely as an engineer, but as a visionary shaping the very infrastructure of Britain and beyond. By the 1850s, Isambard Kingdom Brunel had already achieved remarkable success with tunnels, railways, and early steamships. Yet his ambitions only grew larger. He envisioned projects that defied conventional engineering wisdom, combining scale, innovation, and technical daring in ways that few could imagine. The culmination of his career came with the SS Great Eastern, a ship designed to surpass everything that had come before it. The Great Eastern was conceived to be the largest ship in the world, capable of crossing the Atlantic without refueling. Brunel envisioned a ship so massive that it could carry thousands of passengers and enormous cargo, powered by both steam and sail. The design was revolutionary: double iron hulls for safety, a massive paddle wheel, and innovative engine systems. Yet the project quickly became a test of patience, engineering skill, and resilience. Shipbuilders struggled with the unprecedented scale. Materials warped under pressure, machinery failed repeatedly, and cost overruns mounted. Despite setbacks, Brunel pressed on. He personally supervised construction, often inspecting every rivet, every joint, and every mechanism. The public and the press were skeptical. Many considered the Great Eastern a folly, a ship that would never sail. Brunel, however, trusted his calculations and his vision. He understood that true innovation often comes with risk, and that failure was only a step toward ultimate success. The launch of the Great Eastern in 1858 was chaotic. The enormous ship, far larger than anything previously built, required complex mechanical systems to move it into the water. Multiple attempts failed. Some feared the vessel would be lost before it even began its voyage. Yet Brunel remained composed, applying his knowledge of physics and engineering to gradually bring the ship afloat. Once launched, the Great Eastern became a symbol of human ingenuity and ambition, proving that scale and innovation could be achieved with careful planning and relentless determination. At the same time, Brunel continued his work on railways and bridges. Projects such as the Clifton Suspension Bridge, which he had designed decades earlier, continued to demonstrate his blend of aesthetic vision and engineering precision. He insisted that structures should not only serve a practical purpose, but also inspire awe. Bridges became more than transportation links. They were monuments to human creativity and technological progress. Brunel's life during this period was defined by constant risk-taking. Every project was an experiment at the limits of materials, knowledge, and labor. He faced opposition from financiers, critics, and even fellow engineers. Yet his results silenced doubt. His career was a narrative of tension and resolution. Obstacles that seemed insurmountable were transformed into triumphs through skill, courage, and imagination. The climax of Brunel's career is not just measured by the size of his ships, tunnels, or bridges, but by his ability to expand the boundaries of engineering itself. His work inspired contemporaries and set new standards for precision, safety, and ambition in infrastructure and transportation. Brunel demonstrated that true innovation requires both vision and relentless action, and that the greatest achievements often come from embracing challenges that others shy away from. By the late 1850s, Brunel had become a symbol of engineering excellence. His legacy was already beginning to take shape, as the projects he completed, despite their challenges, would influence generations of engineers, architects, and innovators. Brunel's life shows that audacity, intelligence, and persistence can transform imagination into reality, and that one individual's vision can reshape the world. Isambard Kingdom Brunel passed away in 1859 at the age of 53, leaving behind a lifetime of audacious engineering and a record of achievement that few could match. His death marked the end of a remarkable career, but his influence would persist for generations. The structures he designed, the tunnels, bridges, railways, and ships, did more than solve practical problems. They transformed the world. The Thames Tunnel, once considered impossible, became a landmark in civil engineering. Brunel's innovations in tunneling laid the foundation for modern underground construction, inspiring future engineers to tackle projects beneath rivers and cities. The techniques he pioneered, such as the tunneling shield, remain integral to contemporary engineering projects worldwide. The Great Western Railway revolutionized travel in Britain. By advocating for broader tracks, straighter lines, and more durable construction, Brunel demonstrated that transportation infrastructure could be efficient, safe, and aesthetically impressive. His bridges and viaducts were not just functional, they were architectural statements, blending utility with elegance. Cities grew around these transportation networks, and commerce thrived along the routes he had envisioned. Brunel's ships, particularly the SS Great Western and SS Great Eastern, changed the nature of maritime travel. They proved that transatlantic steamships could be reliable, fast, and large, paving the way for global trade and international travel. He inspired innovation in ship design, materials, and propulsion, influencing engineers for decades. Beyond specific projects, Brunel's approach to engineering, combining audacity, precision, and vision, became a model for future innovators. He demonstrated that risk and creativity were essential components of progress. His career showed that engineering was not simply about solving problems, but about imagining possibilities and pushing the boundaries of what society believed could be achieved. Brunel's legacy also lies in his ability to inspire people. Workers who built his projects often spoke of his determination, attention to detail, and willingness to confront danger alongside them. Investors and critics may have doubted him, yet the results of his work were undeniable. His life story became a lesson in persistence, courage, and innovation, influencing generations of engineers, architects, and dreamers. Today, Brunel is remembered as one of the greatest engineers in history. His bridges still span rivers, his tunnels still carry traffic, and his railways continue to connect cities. His pioneering spirit laid the foundation for modern engineering, transportation, and infrastructure. The audacity of his vision reminds us that true progress requires imagination, courage, and the willingness to challenge conventional limits. Isambard Kingdom Brunel's life is proof that one individual's vision can reshape the physical and social world. He demonstrated that engineering is more than construction. It is the art of transforming possibility into reality. From tunnels beneath rivers to bridges over valleys and ships crossing oceans, Brunel's work continues to influence the way we travel, trade, and connect. As we reflect on his achievements, we are reminded that innovation often comes at the edge of risk. Brunel's daring ideas, his relentless pursuit of excellence, and his ability to turn challenges into triumphs ensure that his legacy will endure for centuries. He was not merely an engineer, he was a visionary who reshaped the modern world, leaving a mark that time cannot erase.